The year is 1513. In a quiet chamber in Constantinople, illuminated only by flickering oil lamps, an Ottoman admiral bends over his desk. Outside, the Bosphorus glows faintly in the night. Inside, something extraordinary is being created, something that should not yet exist. On a sheet of finely prepared gazelle-skin parchment, he carefully draws coastlines of a world that, in his time, is only partially known. The outlines of South America appear with surprising confidence. The western coast of Africa is placed with striking proportional accuracy, but the most controversial element lies far to the south. There, beneath everything else, appears a landmass that closely resembles Antarctica. The problem is simple. Antarctica would not be officially discovered for another 3 centuries. This is the famous map associated with Ottoman admiral and cartographer Piri Reis. For centuries, the map was lost to history until it resurfaced by accident in 1929. During cataloging work in Topkapi Palace, researchers examining Ottoman archives discovered a rolled fragment of parchment made from animal skin. The document was dated to the Islamic year 919, corresponding to 1513 CE, and it bore the signature of Piri Reis himself. What immediately shocked scholars was not just its age, but its content. Piri Reis left handwritten notes directly on the map explaining how it was constructed. According to his own account, the map was compiled from approximately 20 different older source maps. Some of these, he claimed, originated from ancient times, possibly even from the era of Alexander the Great. He also stated that one of his sources was a map once belonging to Christopher Columbus. At first glance, the map appears to depict the Atlantic Ocean, with recognizable outlines of Africa and South America. However, the southern portion is where controversy begins. Several researchers argue that this section resembles the coastline of Antarctica, particularly the region known as Queen Maud Land. What makes this claim so controversial is the fact that this coastline has been buried beneath thick ice for thousands of years. Geological studies suggest that large portions of this land have not been exposed for roughly 6,000 years, long before recorded history. This raises a difficult question. How could a 16th century navigator possibly have access to such information? The map gained renewed attention in the 20th century when it was studied by the United States military. Lieutenant Colonel Harold Z. Ohlmeyer, a cartography specialist, compared the Antarctic portion of the map with modern seismic data collected during scientific expeditions. His conclusion was unexpected. He noted that certain coastal features on the Piri Reis map appear to align with subglacial structures beneath Antarctica's ice sheet. Further studies conducted by institutions such as MIT and naval hydrographic experts reported similar patterns of resemblance, deepening the mystery. Another puzzling element is the map's longitudinal accuracy. The placement of South America appears far more precise than should have been possible in 1513. At that time, sailors had no reliable method for determining longitude at sea. That problem would not be solved until the invention of the marine chronometer in the 18th century. Yet the map still manages to position continents in a way that closely resembles modern geography. Mainstream historians offer a simpler explanation. They argue that the supposed Antarctic coastline is not Antarctica at all, but rather a distorted extension of South America, misinterpreted through centuries of analysis. According to this view, Piri Reis did not possess advanced knowledge of unknown continents. Instead, he compiled and merged the best available Portuguese and Spanish nautical charts of his time. Any resemblance to Antarctica is considered coincidental, a result of selective interpretation. However, critics of this explanation point out inconsistencies. Certain angles, coastal shapes, and structural patterns do not align neatly with South America. Instead, they appear oddly consistent with Antarctic geography, as revealed by modern ice-penetrating surveys. This leads to a deeper question. Where did Piri Reis actually obtain his source material? In his own notes, he repeatedly refers to ancient and lost charts. Some modern researchers, such as Charles Hapgood, suggested that these sources may have originated from a far older maritime civilization, possibly predating known history. Others propose that fragments of ancient geographic knowledge survived through major centers of learning, such as the Library of Alexandria, later being copied and transmitted through medieval maps. Yet no original source maps used by Piri Reis have ever been discovered. and that leaves the mystery unresolved. If the map of Pyre Reefs was not strange enough on its own, another equally puzzling artifact appeared less than 2 decades later in France. In 1531, the French mathematician and cartographer Orens Fine produced a world map that introduced a different but equally disturbing mystery. Unlike earlier maps that only hinted at unknown southern lands, Fine's work depicted an entire continent surrounding the South Pole. This landmass is shown in remarkable detail. Mountain ranges stretch across its interior. Rivers appear to flow from elevated regions toward the coast. Bays and inlets carve deeply into the shoreline, giving the impression of a fully structured and inhabited geography. But the most controversial aspect is that this continent appears ice-free. In other words, Antarctica is shown as it would look without its current ice sheet. Orens Fine was not an obscure or speculative figure. He was one of the leading scientific minds of Renaissance Europe, known for his mathematical work, astronomical tables, and instrument design. His maps were considered serious scientific output, not imaginative drawings. The scale of the southern continent on his map is also noteworthy. It spans roughly 6,500 kilometers, while modern measurements place Antarctica at about 5,500 kilometers across. For a 16th century reconstruction of an unknown landmass, the proximity is striking. Even more intriguing are the internal features. The mountain chains depicted in Fine's map resemble what we now know as the Transantarctic Mountains, which divide the continent into eastern and western regions. These mountain ranges were only confirmed in the 20th century through modern exploration and geophysical analysis. The map also shows river systems flowing from the interior toward the coast. At the time, such features were dismissed as symbolic or theoretical. However, later scientific studies using seismic and radar technology revealed hidden subglacial valleys and drainage patterns beneath Antarctica's ice sheet that loosely correspond to these drawn features. Coastal indentations on the map also appear to align with modern reconstructions of Antarctic bedrock, including regions resembling the Ross Sea area. Fine himself claimed that his work was based on older sources. Like many Renaissance scholars, he had access to translated manuscripts preserved in monasteries and Byzantine archives. This raises a persistent question. What exactly were those sources? In the 20th century, historian Charles Hapgood revisited Fine's map and suggested it may have been derived from even older geographic knowledge, possibly transmitted through lost cartographic traditions. Mainstream historians, however, offer a simpler explanation. They argue that Fine's Antarctic continent is not a real depiction, but rather the theoretical concept of Terra Australis Incognita, the unknown southern land. This idea originated in ancient Greek geography. Thinkers such as Aristotle speculated that a large southern continent must exist to balance the known land masses in the northern hemisphere. Renaissance cartographers inherited this assumption and often included speculative southern continents in their work. From this perspective, Fine was not mapping Antarctica, but illustrating a long-standing theoretical idea. Yet this explanation does not fully resolve the issue. The placement of mountains, rivers, and coastlines is not random. When compared with modern Antarctic data, certain structural alignments appear unexpectedly consistent. If these similarities are coincidental, they involve an unusually high level of geographic precision for pure speculation. This raises another possibility. Could Fine and Pyre Reefs have drawn from a shared, older tradition of mapping? Both maps were created within a relatively short historical period. Yet both appear to contain knowledge far beyond what should have been available at the time. Some researchers propose that fragments of ancient maps survived through multiple channels. Lost libraries, copied manuscripts, or fragmented maritime records passed through civilizations such as the Greeks, Byzantines, Arabs, and possibly even earlier unknown cultures. The most speculative theories suggest the existence of a prehistoric maritime civilization that mapped the world before major climatic changes altered Antarctica's ice coverage. If such knowledge existed, it would explain why multiple Renaissance maps seem to contain consistent but seemingly impossible geographic information. However, no physical evidence of such a civilization has ever been found. As a result, the mystery remains open, suspended between historical theory and unexplained cartographic precision. And just when the pattern seems isolated to a few maps in Europe and the Ottoman world, another discovery emerges. this time pointing to the Arctic, where a completely different kind of impossible geography appears. In 1569, Flemish cartographer Gerardus Mercator produced one of the most influential maps in history. Known for developing the projection system still used in modern navigation, Mercator was not an obscure figure or speculative thinker. He was a highly respected scientist whose work laid the foundation for centuries of cartography. Yet within his famous world map lies another mystery, this time focused on the Arctic. In a polar inset, Mercator depicted the far north in a way that defies both expectation and experience. Instead of an ice-covered wasteland, the North Pole is shown as an open sea surrounding a massive central landform. At the center of this region stands a large mountain, described in his notes as a powerful magnetic structure. Surrounding it is a swirling ocean current, as if the waters themselves are drawn inward and then pushed outward again. From this central sea, for large rivers flow symmetrically outward, dividing the Arctic region into 4 distinct land masses. Mercator labeled the central formation as Rupes Nigra, the Black Rock. According to his description, this mountain was enormous, measuring dozens of miles in circumference, and acted as a source of magnetic influence affecting navigation. To modern readers, this image resembles mythology more than geography. Yet Mercator was not known for inventing fantasy. He was deeply involved in studies of magnetism, navigation, and Earth's physical properties. His Arctic map is based on a now-lost source, a 14th century travel account known as Inventio Fortunata. This text was allegedly written by an English monk who described a voyage to the North Pole and its surrounding lands. The strange part is that Inventio Fortunata was widely referenced in medieval scholarly writings, including works associated with figures such as John Dee. Yet no complete copy of the text has survived. Only indirect references remain, and Mercator's map is one of the only visual representations of its claimed content. The geography surrounding the Arctic inset on Mercator's map is, however, surprisingly accurate. Greenland, Iceland, and Northern Europe are placed with impressive precision for the 16th century. This accuracy contrasts sharply with the speculative nature of the polar region itself. Modern science has revealed that the Arctic Ocean does contain a deep central basin surrounded by underwater ridges. While it does not match Mercator's description literally, the structural resemblance has led some researchers to question whether his source material contained genuine geographical data. The mainstream interpretation is far more conservative. According to historians, Mercator's Arctic is a blend of medieval mythology and classical cosmology. The 4 rivers are linked to ancient symbolic traditions, such as the rivers of paradise described in religious texts. The central mountain represents the Axis Mundi, a mythological concept describing the center of the world connecting heaven and earth. From this perspective, Inventio Fortunata is either a fictional or heavily exaggerated travel narrative, and Mercator simply incorporated it as symbolic geography. However, this explanation does not fully account for Mercator's scientific rigor in other areas of his work. He carefully distinguished between measured geography and reported or theoretical regions in many of his maps. This raises a key question. Why would a scientist with precision include such a detailed Arctic structure unless he considered his sources credible? Further complicating the issue is the fact that some elements of his Arctic coastline, outside the mythical center, bear a loose resemblance to actual Arctic geography. Not exact, but closer than expected for a purely imaginative construction. Some researchers suggest that Inventio Fortunata may have preserved fragments of earlier exploration accounts. Norse voyages, documented in sagas, reached Greenland and possibly further west. It is possible that oral or written traditions of northern exploration survive in fragmented form. Others propose an even broader hypothesis, that Arctic knowledge may have been transmitted across ancient maritime cultures long before medieval Europe, later surviving only in partial and distorted forms. Still more speculative theories suggest that warmer climatic periods, such as a Holocene climatic optimum, may have allowed early seafaring cultures to explore regions now permanently frozen. In such a scenario, older geographic knowledge could have been preserved and later reinterpreted through medieval scholarship. Yet despite these theories, no direct evidence of such a comprehensive Arctic mapping tradition has ever been discovered. Mercator's map therefore remains suspended between symbolism and possibility, between inherited myth and unexplained precision. And while the Arctic raises questions about myth and navigation, another map from the Ottoman world presents a different kind of puzzle, one involving oceans that Europe had barely begun to cross. In 1559, another unusual map emerged from the Ottoman world. Unlike the Piri-Reis map, which focused mainly on the Atlantic, this one shifted attention to an even larger mystery, the Pacific Ocean. The creator was an Ottoman cartographer named Ahmed, a figure about whom very little is known. Yet the map attributed to him presents a serious historical problem. At the time Ahmed was working, the Ottoman Empire had no direct presence in the Pacific. Its naval power was concentrated in the Mediterranean, the Black Sea, and the Red Sea. There were no Ottoman expeditions crossing the vast waters between Asia and the Americas. And yet, Ahmed's map seems to show the Pacific world with remarkable detail. The western coastline of the Americas appears clearly defined, stretching from northern regions that resemble Alaska down through California and all the way to South America. Across the ocean, the eastern coastlines of Asia, China, Japan, and Southeast Asia are also represented with unusual clarity. Scattered between them are island chains positioned in ways that resemble the Pacific archipelagos. What makes this extraordinary is timing. European contact with the Pacific was still extremely limited. Vasco Núñez de Balboa had first seen the Pacific from Panama in 1513. Ferdinand Magellan crossed it in 1521. But his expedition suffered catastrophic losses. By 1559, detailed Pacific knowledge should have been rare, fragmented, and highly protected by Spain and Portugal. Yet Ahmed's map seems to show coastlines with precision that European maps would not fully achieve until centuries later. California and Baja California appear with recognizable shapes. The Pacific Northwest is hinted at in a way that predates official Spanish mapping of that region. Even northern coastlines resembling Alaska are visible, despite Alaska not being formally explored by Europeans until the 18th century. The Asian side of the Pacific is equally impressive. Japan and China appear proportionally closer to reality than many contemporary European maps. Island groups scattered across the Pacific are placed in roughly believable locations. The obvious question is, where did Ahmed get this information? There is no clear documentation explaining his sources. Mainstream historians argue that the answer lies in espionage and trade. The Ottoman Empire had extensive intelligence networks. Captured sailors, stolen Portuguese charts, and intercepted Spanish navigation data could have provided fragments of information. Through trade routes connecting Europe, the Middle East, and Asia, Ahmed may have gained access to geographic material not officially available. From this perspective, the map is not evidence of impossible knowledge, only the result of gathering scattered intelligence. But critics point out a problem. Portuguese and Spanish Pacific charts of the mid-16th century were themselves incomplete and often inaccurate. Longitude remained unsolved. Even experienced European navigators struggled to place coastlines correctly relative to each other. So, how did an Ottoman cartographer, far removed from Pacific exploration, create something that in some areas appears more coherent than the maps of the explorers themselves? The longitude problem is especially troubling. Without an accurate timekeeping device, precise longitudinal positioning at sea was almost impossible. This challenge would not be solved until the marine chronometer in the 18th century. Yet Ahmed's Pacific coastlines appear positioned with surprising consistency. This has led some researchers to propose alternative explanations. One theory points toward Chinese maritime exploration. During the early 15th century, the massive treasure fleets of Zheng he sailed across Asia, India, and East Africa. Some fringe researchers suggest these fleets may have ventured further east into Pacific waters. If Chinese charts existed showing Pacific coastlines, they could have entered Ottoman archives through trade along the Silk Road. Another theory looks to Polynesian navigation. For thousands of years, Polynesian sailors crossed enormous distances using stars, ocean currents, and wave patterns. Their knowledge of Pacific geography was unmatched. Could fragments of that knowledge have been recorded and eventually transmitted westward A more radical theory suggests that ancient seafaring civilizations may have mapped Pacific coastlines long before the age of exploration, with fragments of that knowledge surviving into later empires. There is no solid proof for such claims, but the Achmed map remains difficult to explain within conventional history. Its existence raises uncomfortable questions. How did an empire without Pacific voyages produce such advanced Pacific geography? Why do some of its coastal details appear ahead of European records? And if Achmed used older sources, where are those source maps now? These questions become even more interesting when we look at a map that was literally stolen because it contained knowledge considered too valuable to lose. Because sometimes the greatest clue is not what a map shows, but how far governments were willing to go to protect it. That brings us to Portugal in 1502 and one of the most famous acts of cartographic espionage in history. In October 1502, one of the boldest acts of espionage in cartographic history took place in Lisbon. A man named Alberto Cantino, working for the Duke of Ferrara, managed to obtain and secretly transport one of Portugal's most guarded state secrets, a world map. This map would later become known as the Cantino Planisphere. At the time, Portugal was at the forefront of maritime exploration. Its ships had rounded Africa, reached India, and begun establishing trade networks across the Atlantic and Indian Oceans. Navigation data was treated as military intelligence. Maps were not simply tools for sailors. They were strategic weapons. Whoever controlled accurate maps controlled trade routes, colonies, and access to wealth. Portugal understood this better than anyone. Pilots were sworn to secrecy. Geographic information was classified. Unauthorized sharing of maps could result in severe punishment. That is why Cantino's theft was such a serious event. He allegedly paid a huge amount of gold to acquire the chart and smuggled it out of Portugal hidden among fabrics and private cargo. The map survived and is now preserved in Biblioteca Estense. What makes the Cantino Planisphere so important is not only that it was stolen, but what it revealed. The map shows the known world with extraordinary detail for 1502. Most strikingly, it includes an extensive outline of the Brazilian coastline. Brazil had officially been discovered by Pedro Álvares Cabral in 1500, only 2 years earlier. Yet on the Cantino map, the coast extends for thousands of miles, showing details far beyond what official exploration records would suggest. Portuguese voyages by that date had only documented part of the coastline. So how was the rest mapped so quickly? The map also shows the African coastline with impressive precision, from the Mediterranean all the way around the Cape of Good Hope and up the eastern coast. The outline reflects knowledge from the voyages of Vasco da Gama and other navigators. But again, the detail seems more advanced than what had been publicly documented. The Caribbean appears with notable clarity as well. Spanish discoveries in the Americas are included, despite the political division established by the Treaty of Tordesillas. This treaty divided newly discovered lands between Spain and Portugal, and the Cantino map prominently marks that dividing line. This shows the map was not just geographic. It was political. It reflected territorial claims and strategic planning. The Indian Ocean and parts of Asia also appear with considerable detail. India's coastline is recognizable. Sri Lanka appears in roughly correct relation to the subcontinent. Southeast Asia is present in forms that suggest access to navigational knowledge beyond public European maps. What makes historians pause is the speed. How did Portuguese cartographers collect this much information in such a short time? Official voyages to many of these places had happened only a few years earlier, and yet the map gives the impression of much longer familiarity. The mainstream explanation is simple. Portugal had been exploring intensively, often in secret. Many voyages were not publicly recorded immediately. Pilots returned with notes, coastal measurements, and route observations that were compiled into official charts. The Cantino Planisphere, according to this view, represents the most up-to-date secret geographic knowledge Portugal possessed. Its accuracy reflects concentrated exploration, not hidden ancient knowledge. But some researchers remain unconvinced. The southern Brazilian coast seems too complete. Its placement relative to Africa appears surprisingly accurate for an age before reliable longitude, and Portugal's violent reaction to the theft raises suspicion. If the map merely reflected a few years of recent exploration, why guard it so aggressively? Some historians suggest Portugal may have discovered Brazil earlier than officially acknowledged and delayed public announcement for political reasons. This would explain why the coastline appears more developed than expected. Others believe Portuguese navigators may have used older Arab or Mediterranean maps as reference guides. The Arab world had preserved centuries of navigational knowledge. Ancient Roman and Phoenician trade networks may also have contributed fragments of geographic memory. There's even speculation that Norse or Basque sailors had partial Atlantic knowledge that entered Iberian archives before Columbus. While none of these ideas are fully proven, they point to one reality. Exploration history may be more complicated than official timelines suggest. The Cantino planisphere proves one thing clearly. By 1502, someone possessed far more geographic knowledge than public history would indicate. Whether that knowledge came from secret expeditions, older charts, or a combination of both remains uncertain. But the theft of the map tells us something important. Empires protected maps because maps contain power. And when power is hidden, history often becomes selective. But perhaps even more mysterious than stolen knowledge is knowledge published openly, years before it should have existed. That brings us to 1507, when a German scholar published a world map that showed an ocean Europe had not yet officially discovered. And on that map, for the first time in history, a new name appeared: America. In 1507, in the small town of St. Didevaux, a German cartographer named Martin Waldseemüller created a map that would permanently change the way the world was seen. It was a massive work, printed across 12 wooden panels and designed to be assembled into a giant wall map. Nearly 1,000 copies were produced, but only one survived. That surviving copy would later be purchased by the Library of Congress for $10 million, making it one of the most valuable historical documents ever sold. But its price reflects more than rarity. It reflects importance, because this was the first map in history to use the name America. Waldseemüller chose the name in honor of Amerigo Vespucci, whose letters argued that the lands across the Atlantic were not part of Asia, but an entirely new continent. That alone made the map historic. But there's another detail, far stranger. Waldseemüller's map appears to show the Pacific Ocean, 6 years before Europeans officially discovered it. At the time the map was published, Christopher Columbus had crossed the Atlantic and reached Caribbean islands. Vespucci had explored parts of South America, but no European had seen the western coast of the Americas. No one had crossed the continent. No one had reached the Pacific. That would not happen until 1513, when Vasco Núñez de Balboa crossed Panama and became the first European to see the Pacific from the American side. And yet Waldseemüller's map shows a large ocean separating America from Asia, not as a vague, empty space, but as a defined body of water. This is the mystery. How could he depict an ocean no European had officially seen? Even more unusual is the shape of South America. It appears as a separate landmass, clearly distinct from Asia. Its eastern coastline follows what explorers had documented, but its western coastline, facing the Pacific, is also drawn. That coastline should have been unknown. No European expedition had mapped it. No ship had sailed along it. And yet there it is. Mainstream historians argue that this was not secret knowledge, but intelligent speculation. By 1507, educated scholars understood that the Earth was round. They also understood that Columbus had not reached Asia directly. If Vespucci was right, and this was a separate continent, then logic suggested there must be another ocean between America and Asia. From that perspective, Waldseemüller simply made an educated guess. The western coastline was hypothetical. The Pacific was theoretical. He filled in unknown spaces based on reasoning. And according to mainstream scholarship, he happened to guess correctly. But critics of that explanation raise an important point. Waldseemüller was not creating fantasy art. He was producing a serious scientific map for scholars. His work was based on the best available geographic information. Every line carried meaning. Every coastline represented deliberate thought. If the Pacific was only speculation, why is it proportioned so convincingly? Why is the distance between America and Asia represented in a way that resembles reality more than chance might suggest? And why, in later editions, did Waldseemüller change his map? In 1513, just 6 years later, He removed the name America and altered parts of the Western geography. It was almost as if he had reconsidered or been pressured to reconsider. Some researchers believe Waldseemüller may have had access to Portuguese charts unavailable to the public. Portugal was deeply secretive about exploration data. If Portuguese ships had reached southern routes around South America earlier than official records admit, such knowledge could have reached scholars privately. Others suggest Spanish navigators may have reported western coastlines earlier than history records. Exploration was often messy, undocumented, or deliberately hidden. Another theory points eastward. China had a long cartographic tradition. Its maps of Asia and surrounding seas were highly developed. Some speculate that Asian geographic knowledge may have reached Europe through trade routes, giving scholars broader context about the ocean beyond Asia. There are even more radical ideas. Some suggest pre-Columbian maps existed showing both coasts of the Americas, preserved in monasteries or private collections. No evidence confirms this, but the idea persists because of the map's unusual confidence. What makes Waldseemüller's work important is not just the naming of America, it's the timing. His map seems to anticipate discoveries before they were officially made. It suggests that geographical understanding may have advanced faster or more secretly than public records reveal, and the fact that he later changed parts of that vision only deepens a mystery. Was he correcting an error or withdrawing information too early? History offers no clear answer. But while Waldseemüller raises questions about Europe's knowledge of the Pacific, another map from the East shows that advanced global geography was not a European invention at all. Centuries before European world empires dominated the seas, scholars in Asia were drawing a world with surprising precision. And one Korean map, created in 1402, may prove that knowledge of distant continents was already circulating across civilizations. In 1402, more than 80 years before Christopher Columbus crossed the Atlantic and decades before Portuguese ships rounded southern Africa, Korean scholars created a world map that would later challenge the idea that advanced cartography was purely a European achievement. This map is known as the Cagnito. Its full name translates roughly as Map of Integrated Lands and Regions of Historical Countries. It was created during the reign of King Taejong of Joseon by Korean scholars and officials working in the royal court. The original version has been lost, but later copies survived and are preserved in Japan. What makes the Cagnito remarkable is its global scope. For a Korean map of the early 15th century, it does not focus only on East Asia. Korea is shown in great detail, which is expected. China is large and central, reflecting its political and cultural importance. Japan appears nearby. But beyond that, the map extends westward across India, the Middle East, Europe, and Africa. And this is where the mystery begins. Africa's shape on the Cagnito is surprisingly recognizable. It stretches north to south in an elongated form, narrowing toward the southern end in a way that resembles reality far more closely than many European maps of the same era. This is extraordinary because in 1402, European exploration of Africa was still limited. The Portuguese had not yet rounded the Cape of Good Hope. That would happen in 1488 under Bartolomé Dias. So how could Korean scholars have access to such accurate African geography? The map also includes Arabia, the Mediterranean, and parts of Europe with a degree of organization suggesting access to substantial geographic knowledge. Mainstream historians explain this through knowledge transmission. Korea was connected to China, and China was connected to the Islamic world through the Silk Road. Islamic geographers had long traded along East Africa's coast and possessed better African knowledge than medieval Europe. Chinese merchants and travelers also carried information across Asia. The Cagnito, according to this view, was simply a synthesis of Chinese, Islamic, and local Korean knowledge. This explanation makes sense, but it leaves one problem. Some researchers argue that the African outline on the Cagnito appears more accurate than the surviving Islamic maps that supposedly inspired it. In other words, if Korean scholars were copying from Islamic or Chinese sources, why does their final result sometimes appear better than the source tradition itself? This raises a possibility that the map drew on older materials now lost. Its preface states that multiple earlier maps were used in its construction, but those source maps have not survived. That missing evidence creates room for speculation. Some historians point to ancient Roman trade. The Roman Empire maintained trade networks reaching India and possibly further east. Roman coins have been found across Asia. Geographic knowledge may have moved farther than written history, clearly records. Others look even earlier. Ancient Phoenician sailors, according to Herodotus, may have circumnavigated Africa under Egyptian command around 600 BCE. If such voyages occurred, fragments of their geographic knowledge could have survived through Mediterranean and Arab scholarship. There is also the Chinese maritime possibility. Though the great treasure fleet voyages of Zhang, he began in 1405, 3 years after the Cognito. Some suggest earlier Chinese voyages may have existed but gone undocumented. If so, maps from those expeditions might have informed the Cognito. Still, there is no definitive proof. What remains undeniable is that the Cognito demonstrates a level of world knowledge far beyond what many people associate with East Asia in the early 15th century. It reminds us that cartographic knowledge was not isolated. Ideas moved, maps moved, knowledge crossed borders long before empires did. And perhaps most importantly, the Cognito shows that global geography was already becoming a shared human project, not purely European, not purely Asian, but interconnected. This challenges the traditional story of exploration as a one-directional process led by Europe. Instead, it suggests a world where knowledge circulated through merchants, scholars, sailors, and diplomats across continents. Yet if the Cognito proves that geographic knowledge moved globally, another map presents an even stranger possibility, not the sharing of knowledge, but the preservation of forbidden or forgotten voyages. A map that claims Europeans crossed the Atlantic a century before Columbus. A map so controversial that historians still argue over whether it is authentic or one of history's most elaborate forgeries. That map is the Zeno map, published in Venice in 1558. It tells a story that could rewrite the history of Atlantic exploration or expose one of the greatest cartographic deceptions ever made. In 1558, in Venice, a man named Niccolò Zeno, the Younger, published one of the most controversial maps in history. He claimed the map was based on letters and records preserved in his family archives. According to his story, those documents had been written by his ancestors, Niccolò Zeno and Antonio Zeno, who had sailed across the North Atlantic in the 1390s. If true, this would place their voyage nearly a century before Columbus. That alone would be extraordinary. But the map itself makes even bigger claims. It shows Greenland, Iceland, the Faroe Islands, and several mysterious lands to the west. Among them are places called Friesland and Estodeland. Friesland appears as a large island between Iceland and Greenland. The problem is that no such island exists. Modern geography has no equivalent for it. Yet for centuries, Friesland appeared on European maps, accepted by major cartographers as if it were real. Estodeland is even more interesting. It appears west of Greenland and has often been interpreted by some researchers as a possible reference to North America. According to the accompanying narrative, this land contains structured settlements, books, and signs of advanced habitation. To some, this sounds like Norse settlements in Newfoundland. In 1960, archaeologists confirmed the existence of Norse settlements at L'Anse aux Meadows, proving that Europeans had indeed reached North America centuries before Columbus. That discovery gave new life to the Zeno controversy. Could the map preserve authentic memories of Norse exploration? The Zeno map's depiction of Greenland is particularly strange. Some of its coastal features appear more accurate than many other European maps of the 16th century. This suggests access to real navigation data. But where would such data come from? The Zeno family was wealthy and politically important in Venice. They had maritime connections and access to naval records. Venice maintained trade links with Northern Europe, making indirect access to Norse knowledge possible. Mainstream historians, however, are highly skeptical. The dominant view is that the Zeno map is a fraud. They argue that Niccolò Zeno the Younger fabricated the story to glorify his family's legacy. By inventing heroic voyages for his ancestors, he could raise the family's historical prestige. Friesland, in this view, is pure invention. Estodeland is fictional geography inspired by Norse legends and travel stories. Any accurate features on Greenland were likely copied from more recent Portuguese or Scandinavian maps. The family letters may have been altered exaggerated, or completely invented. This explanation is compelling, but it leaves unanswered questions. If the map was an obvious fraud, why did serious cartographers accept it? Figures like Gerard Deus Mercator and Abraham Ortelius included Friesland in their own maps. These were not careless men. They had access to the best geographic knowledge of their time. Why would they trust false information? One answer is simple. The map looked convincing. Its details were sophisticated enough to fool experts. But another possibility is that it contained a mixture of truth and invention. Perhaps the Zeno story was built around genuine fragments of older northern exploration. The Norse had unquestionably reached Greenland and Newfoundland. Their sagas preserved accounts of western lands. Those stories could have reached Europe through Icelandic or Scandinavian channels. Venetian merchants, through northern trade, may have heard such stories. It is possible the Zeno family had access to real oral traditions or partial records. Later publication may have expanded or distorted them. Friesland itself might be a misidentified island, possibly Iceland, the Faroes, or navigational distortion created through copying errors. Medieval cartography often produced phantom islands through repeated mistakes, but Aristotle remains harder to dismiss. Its Western placement and described civilization aligns strangely with what we now know about Norse Atlantic settlements. This raises an unsettling possibility. What if parts of the Zeno map preserved genuine knowledge of Atlantic crossings long before Columbus? Not necessarily Venetian exploration, but transmitted Norse memory. If so, the map becomes less a hoax and more a corrupted archive of forgotten voyages. That would explain both its errors and its truths. A flawed memory, preserved through generations. The Zeno map sits on the border between myth and evidence. Too inaccurate to trust fully. Too strange to dismiss completely. And like so many mysterious maps, its greatest power lies in what it forces us to ask. How much knowledge of the Atlantic existed before official history says it should? And how much of that knowledge was lost, distorted, or buried? The next map takes us back even further. Back before Columbus. Before the great oceanic empires. Back to a Venetian monk whose masterpiece may preserve ancient geographic traditions older than Rome itself. That map is the Fra Mauro map. Around 1450, decades before the great European age of exploration officially began, a Venetian monk created what many historians consider the most advanced world map of the medieval era. His name was Fra Mauro. He lived and worked on the island monastery of Murano near Venice, where he operated a professional cartographic workshop that served merchants, nobles, and rulers. His masterpiece became known as the Fra Mauro map. It was enormous, over 6 feet in diameter, and unlike most European maps of its time, it placed south at the top and north at the bottom. This was not a mistake. It reflected the influence of Islamic cartographic traditions, which Fra Mauro openly acknowledged as one of his important source systems. That detail matters because it reveals something critical. Fra Mauro was not building his world map from European knowledge alone. He was combining information from multiple civilizations. His map includes over 3,000 written notes explaining locations, trade routes, historical accounts, and source references. That makes it one of the most documented maps of its age. But the most controversial part of the map is Africa. Fra Mauro drew the African continent extending far southward and curving eastward around a southern tip, essentially showing the possibility of circumnavigating Africa. This was nearly 40 years before Bartolome Dias officially rounded the Cape of Good Hope in 1488. Even more shocking, one of Fra Mauro's written annotations describes a ship that allegedly sailed around Africa's southern edge in 1420. That is 68 years earlier than Dias. If true, it would completely change the timeline of European maritime discovery. Fra Mauro's map also shows the Indian Ocean as open and connected to the Atlantic. This directly contradicted older European ideas inherited from Claudius Ptolemy, who believed the Indian Ocean was enclosed by land. Fra Mauro rejected that model, and history proved him right. His depiction of India, Sri Lanka, Southeast Asia, and parts of the East Indies is also surprisingly sophisticated. The coastlines are not perfect, but they are far better than what many European maps of the time achieved. This suggests access to serious maritime intelligence. Mainstream historians explain Fra Mauro's accuracy through synthesis. Venice was one of the greatest trade centers in the world. Merchants arrived from the Islamic world, Asia, and Africa. Travelers brought stories, measurements, and practical knowledge. From Morrow collected all of it. He also used Islamic geographic texts, reports from merchants, and information from explorers. From this perspective, his map represents the peak of medieval knowledge integration, not secret ancient knowledge, just excellent scholarship. And that explanation is strong. But certain details remain uncomfortable. The 1420 circumnavigation note is oddly specific. For Morrow did not write vague legends. He documented practical navigation reports. So where did that story come from? Some suggest it may refer to Arab sailors. The Arab world had navigated East African waters for centuries and may have possessed knowledge of southern routes. Others argue it may refer to secret Portuguese voyages. Portugal was aggressively exploring the African coast at that time. From Morrow's map was commissioned by Afonso V of Portugal, which means he may have had access to state secrets. If Portuguese ships had quietly reached farther south before official public announcements, From Morrow might have known. There is also the possibility of ancient continuity. Phoenician sailors reportedly circumnavigated Africa around 600 BC under Egyptian command. According to Herodotus, Roman trade with India is historically confirmed. Ancient maritime knowledge could have survived in Arabic libraries and later reached Phoenician scholars. From Morrow himself frequently referenced ancient and foreign sources. He treated them as legitimate. This suggests that medieval Europe may have inherited more ancient geographic knowledge than modern history usually acknowledges. His south-up orientation is also symbolically important. It reminds us that geography depends on perspective. North at the top is not natural, it is cultural. For Morrow's world was built from many perspectives: European, Islamic, Asian, a shared memory of geography. And that may be the map's greatest lesson. Exploration was not always discovery. Sometimes it was recovery. Recovery of knowledge that had been lost, fragmented, and rediscovered. From Morrow's map stands at the edge of the medieval and modern worlds, looking backward into ancient knowledge and forward into the age of empire. But when we place From Morrow beside all the other maps in this investigation, a pattern begins to emerge, a pattern too strange to ignore. And that brings us to the final question. What if history's map of discovery is incomplete? Across centuries, these 10 maps tell a story far stranger than simple exploration. Individually, each can be explained: a copying error, a lucky guess, a myth mistaken for geography, a hidden expedition, a lost source. But together, the pattern becomes harder to dismiss. The Pyrie Reis map suggests knowledge of coastlines that should not have been available. The Orance Fine map appears to depict Antarctica beneath ice. The map of Philippe Boich divided Antarctica into two landmasses centuries before modern seismic studies confirmed subglacial divisions. Gerardus Mercator preserved a strange Arctic geography based on lost northern sources. Ahmed's Ottoman Pacific chart raises questions about impossible oceanic knowledge. The Cantino planisphere reveals exploration knowledge guarded as state secrets. Martin Wald Simler mapped the Pacific before official European discovery. The Cognito proves that world geography was not isolated in Europe. The Zeno map preserved the possibility of pre-Columbian Atlantic memory, and the From Morrow map openly admits its dependence on ancient and foreign knowledge. What connects them is not perfection. None of these maps are flawless. Many contain errors, distortions, misplaced islands, broken coastlines. But perfection is not the point. The mystery is why certain correct details appear so early. Why do fragments of accurate knowledge appear before official discovery? Why do multiple map makers, in different countries and centuries, seem to preserve pieces of geographic truth ahead of their time? There are several possible explanations. The first is the simplest: hidden exploration. History records official voyages, but unofficial voyages may have happened long before. Secret missions, commercial expeditions, state-sponsored journeys never announced publicly. Empires often hid knowledge for strategic reasons. Portugal did it. Spain did it. The Ottoman Empire did it. That much is documented. The second explanation is lost transmission. Knowledge travels. Maps are copied. Charts are translated. A Phoenician route becomes a Greek text. A Greek text becomes an Arabic manuscript. An Arabic manuscript becomes a Venetian map. Over centuries, fragments survive even when the originals vanish. This would explain why so many cartographers refer to older sources that no longer exist. The third explanation is ancient exploration, more controversial, but not impossible. Ancient sailors were far more capable than older historians once believed. The Phoenicians crossed vast seas. The Polynesians crossed the Pacific. The Norse crossed the Atlantic. It is possible that ancient maritime networks explored farther than surviving records reveal. If so, some of that knowledge may have survived only in fragments. And then there is coincidence, the mainstream explanation for many of these maps. Humans are pattern-seeking creatures. We see meaning in vague lines. We project modern geography onto ancient distortions. Sometimes resemblance is just resemblance, not proof. This explanation matters because it keeps us cautious. Not every mystery is evidence. Not every anomaly rewrites history. But even caution has limits. When anomalies repeat, they deserve attention. And these maps repeat the same anomaly, knowledge appearing too early. Maybe history is exactly what we think it is, a gradual process of discovery, mistakes corrected over time, knowledge expanding step by step. But maybe history is less linear than that. Maybe civilizations forget. Maybe knowledge collapses and returns. Maybe discovery is often rediscovery. Maps are more than drawings. They are memory. Memory of voyages. Memory of trade. Memory of stories. Memory of worlds once known. And when those memories survive across centuries, they leave traces. Traces that challenge official timelines. Traces that force uncomfortable questions. Not because they prove conspiracy, but because they prove complexity. History is rarely clean. It is layered, messy, selective, incomplete, and perhaps that is the real lesson of these maps. Not that ancient civilizations secretly knew everything, but that human knowledge has always been bigger, older, and more connected than the stories we simplify. The world was never discovered all at once. It was remembered in pieces, lost in pieces, and found again in pieces. And sometimes if we look carefully at old maps, we can still see those missing pieces staring back at us.